Okay, everybody, welcome to What No One Told Us, episode 2. For episode 2, Jake and I are going to be interviewing one of our friends from college named Ben Keener. He's a mechanical engineer. He has a bachelor's of science in mechanical engineering and a minor in computer science and probably mathematics and applied sciences. He's really just getting all the degrees. And so
Just
Ben,
math and CS.
what?
Just math and CS.
Oh, okay. Just
Okay.
2. Yeah. Just like everybody else.
He's not that big of a show off.
Yeah, no, yeah.
I'm only a little bit of a tryhard.
Well, you did more than I did. And so Ben and I actually had the privilege of working together for a little while I was in school. He had graduated at a company named Stemco, so I'm familiar with some of the stuff he did there. And then I actually don't know what he's been doing recently at this next company he's working at, and so hopefully he'll be able to give us some insight on that today. Anything to add, Ben, about your
No.
experience?
Good overall coverage there.
So we'd like to start with just how you got into mechanical engineering. We know you went to LeTourneau. That's where we all went so far on the podcast. And so if you could just share a little bit about kind of what drew you to engineering, and then why LeTourneau and kind of your school experience.
And I guess specifically mechanical. Like what drew you to mechanical engineering? Yeah.
Yeah. Okay. So, I mean, growing up and specifically in high school, I knew I really liked math and science. I mean, my parents were both scientific degree areas, so I've always been good at that and liked that. So I knew I wanted something in that general area. It wasn't until in high school I had a teacher who was actually a degree engineer. And she was primarily a math teacher, but she also taught this class that was just called engineering, where basically what we do is we go in there and do fun projects. We build stuff. So we do stuff with like the little Lego robots that you guys have both used in college.
Nothing like reminding Jake and I how far behind we were going into college. Josh Woodman, our last guest, did the same thing. Oh yeah, I was coding in high school. And Jake and I were over
I
here
did this
like,
in high school, but you probably experienced when you were a senior in college.
But
So basically, I mean, we did those. We did just random projects. Like we do build model rockets, just like from something from a kit. One of the cool projects was we built a concrete boat. So you had to try and figure out how to get something literally made of concrete to float. So just
How was everyone's high school experience so much better than mine?
Jake, and
I
mine was
didn't-
so much better, so much worse than yours. We are.
Like, I think my high school project was like make a car out of food.
What were you
My
saying,
parents
Ben?
pay a lot of property taxes for those schools.
That's fair. Was it public school still?
Yes, it was.
Okay. But maybe a little bigger city.
Yeah, so basically going through that kind of exposed me to engineering first. And in talking to that teacher and doing research, I realized that engineering would be a good fit for me and it's something I would enjoy, just being able to design and build stuff and use my hands. I chose mechanical engineering when I got to school because I didn't know that much about any of them, but I knew mechanical was the most broad and you could do the most with it. So going in, I just decided, if the more stuff I can do with my degree, the more likelihood I have of finding something in the field of engineering I like. So I went with mechanical.
It's definitely a smarter choice than what I did. Picked a very specific degree.
Maybe if I get a really specific, I'll get a really specific job. Well, hopefully you'll be able to clear up some of those questions for some younger people looking for mechanical engineering degrees.
Mm-hmm.
Yeah, I guess one of the questions, I guess we haven't really talked about on any of the other podcasts, but like engineering school, I guess how would you describe like the overall experience? And like, I shouldn't ask you this because for those who are listening, Ben is incredibly smart. But for the rest of the people on the podcast, Cole and I, engineering school is a little more difficult than I would say most majors. So I guess, Ben, if you just want to talk about like your experience in school, some of the classes you took specifically in mechanical that, or I guess I wouldn't have taken that Cole would have also taken.
Yeah, so I mean, engineering in general, like it's a lot of work. Like you can look at things in a different way, like saying stuff is hard. in engineering school, one of the biggest things that like I think hard means to everyone is it's just a lot of work. And even for me, it was a lot of work. I mean, I may not have always shown how much work it was, but I did work hard. It wasn't just a breeze the entire way through. But yeah, a lot of the classes I took, so there's a lot of math, obviously. So I took calculus 1, 2, 3, differential equations. At LeTourneau, you guys know this, but at least mechanical engineering, you automatically get a math minor just because they make you take that many math classes by default.
Don't remind me.
Yeah. But then more specific mechanical engineering questions, or classes, not questions. It starts off with statics, which is basically the study of things, of like forces and everything for something that's just sitting still. So like basically how to design a table to sit there still. Moving on from statics, which is stuff when everything is still, the next class in the line is dynamics, which is how to design stuff and calculate everything when it's all moving. And it basically goes in that progression with a lot of stuff. It kind of starts off with a simpler version and goes to more complex. There's similar stuff with like thermodynamics and heat transfer. It starts off more base level and then gets more specific as you go further on throughout your degree.
So I guess as you were in school taking these classes, was there anything that you thought, all right, I maybe want to go down this path of mechanical engineering versus a different path of mechanical engineering?
So I guess the two major fields of mechanical engineering that I was exposed to that they taught at LeTourneau, which there's a ton of them, but the two major ones we had were mechanics, which is the first route I was talking about, like structures, or slightly more structural. And then the second one is thermodynamics and heat transfer, which is a little more theoretical. I liked the mechanics side, getting to, because that's like machines and more designing stuff. That's more of what I do now. So I really enjoyed that.
Okay, gotcha.
Me too, but then I got a job on the other side. But that's okay. People ask me thermodynamics.
You didn't pay attention to? Here you go.
Oh, yeah, like, hey, what's heat rate? I don't know. I definitely missed some questions on it in college. I can tell you that. So, one experience that I remember you telling me about as an underclassman was, I think it was Dr. Caldwell's class, one of your project classes, or was it with Dr. French? I don't know. It was one of your kind of like electives that you really enjoyed. I don't remember what it's called. I don't know if this is ringing any bells for you or not.
There's a couple classes, just based on the professors, there's a couple different classes. Do you have any like little more detail on the story? Maybe I can.
I don't know. Maybe, I guess it was EDM. I think you enjoyed that class, Engineering Design Methodology, right?
Yeah.
Yeah,
I had Caldwell for that.
And so what'd you do in that class?
Okay, so engineering design methodology, over the course, you're in a group for the class, but over the course of the class, you decide early on that your group is going to design or improve something that exists or come up with some variation of something. And really the class isn't about the project. The project is just a means to do everything through. So that class is really just about the different ways people come up with and design stuff, which is really interesting. Dr. Caldwell there actually, I think, is doing like PhD, having or grad students in this type of field. But basically it's saying like the different ways different people think and come up with ideas and testing all those out. And as part of that, it's like how to evaluate whether or not, a certain design is good. So there's all these different tools. One of the big ones he came up with was he taught us, he didn't come up with it, was house equality, where you just evaluate basically what's important in the thing you're designing. Another thing, Cole, you're familiar with this from STEMCO, is FMEA. It stands for Failure Modes, Effects, and Analysis. It's basically a way of looking at where risk is in a certain design to figure out what needs improved.
And do you think that helped you in your career? That class was like that a valuable class for you to take?
So that FMEA portion definitely was, because we used that tool at the company I started at right after college. But in general, like just being able to see different ways of thinking it definitely opens you up to realize that the way you design and the way, or like the way I think and I design isn't the only way to do it, and that there's plenty of other good ways out there. Like I don't think I'd sit down today and use any specific thing that I use from that. Maybe in general, it changed the way I think a little bit. I can't point to anything specific, but I did definitely enjoy taking the class and think it's valuable.
Okay. So when you were in college, did you have any internships before getting your first job after college?
Yes. So my last summer, the summer after my junior year, I interned at STEMCO, the company I got hired at right after college. So I interned there full time that summer, and then since it was in the same town as LeTourneau, I worked there part time throughout my senior year.
Okay, I guess can you just expand upon a little bit about what STEMCO does and what your position was at STEMCO? Yeah,
so STEMCO is basically they make parts in the trucking industry, so 18-wheelers, tractor trailers. It's the company started out doing seals for the wheels. My department specifically worked on bringing newer technologies into it. So it was based on adding electronics and telematics, basically adding tracking information and safety information that bigger fleets can look at from a centralized location and see where all their trucks are. A lot of the products were based around wheel ends. So we had automatic tire inflation systems, tire pressure monitors, and all this stuff would be tied back to a telematics system. So one guy sitting at like the hub for some massive tractor trailer company can look at all the trailers and trucks and say, truck number 274 over in Des Moines, Iowa needs to pull over because his tire's flat.
Okay, so at STEMCO, I guess first off, what size of a company was STEMCO? Was STEMCO like small, medium, like massive, large, or?
I'd still probably say medium-sized company. I think at the plant I was at, there were 200 or 300 people working there.
Okay.
Cole, does that
sounds
right?
about right. Maybe a little more with like a couple different shifts there was some manufacturing there, so definitely the engineering department was quite a bit smaller than that, but the overall plant 300 to 300 is about right.
Yeah.
Which that was bringing up my next question. At STEMCO there, was it strictly just the engineering, or were you manufacturing all the parts that you were designing there as well?
Yeah, so it did include manufacturing. There was kind of an office section and a plant section where, we had salespeople, accounting,
okay,
HR, the whole thing there. But yeah, there was like the design would happen, and then the parts we would design would go get manufactured out on the floor. That was one of the cool things about working there is you got to see in person a lot of the stuff you design. Most of what I did was what they call process engineering there. It was basically designing and upkeeping assembly lines. And a lot of those designs came from what was already existing. The people working on it said, hey, this is a problem area here. We need some way to fix it. So then the process I would go is go look at the machine, try and figure out what the problem is, come up with different ways to fix it. And then once I come up with a solution, it gets manufactured. I go out on the line, I install it, and I test it, and then check with the people using it. Hey, does this fix your problem?
Okay, gotcha. How big of your specific design team were you working on?
My department specifically, it was a little smaller than the core side engineering, as it was called. It varied a little. It was probably somewhere between 5 to 9 people in that range over the few years I worked there.
Mm-hmm.
Gotcha.
And so, I guess like you did the same job as an intern as you did as an engineer, right? You just kind of smoothly transitioned from intern into engineer.
Yes, I did. Yes, so more of the projects I was doing as an intern were what I was saying, where it was, hey, something's wrong here, go figure out a way to make it better. Which I still did that when I was there full time, but I also started getting more projects where it was, hey, we have this new thing we want to design, or we want to completely revamp this assembly line here, design it from scratch instead of design from what's already there.
Okay, that makes sense. That's also a little nicer than the redo projects. They're sometimes a little weird because you have a lot more constraints. You can't be as creative.
Yes.
And I always felt like it was easier when it was fresh and I was starting from my own design rather than trying to figure out why someone did it the way they did and do the modification.
That's something I'm actually dealing with. I've been dealing this week at my current job. Is inheriting a project from someone else where I'm trying to figure out, okay, what the heck's going on here? Going back and doing it the way I like versus the way they had it. So, yeah, I agree. I do like starting from scratch on something. It's a fun experience for me. That's the part of being an engineer in my job that I like, is just basically having a blank sheet of paper and getting to come up with something.
Yeah. So when you were at Stemco and you were doing these modifications or your original design, what software were you doing this design in? Was this SolidWorks or AutoCAD or Pro E?
We used. That's what Laterno used for all of its computer-aided design, and that's what Stemco used, and my current company. So SolidWorks is the only CAD tool I've really used.
It's the best. I'm maybe partial, but I truly enjoy SolidWorks better than any other one I've ever even tried using.
From people who use both,
SolidWorks
I hear
sponsor here.
Creo from people who've used both, but they also say they're pretty similar.
I think I used Creo a little bit at K2M because, like, the original, when they first started, one guy only knew how to use Creo, and so like there was original drawings made with that, and so they kept one license so that they could access those instead of just converting everything to SolidWorks. I was like, this is kind of stupid. So I mean, that brings up another question. Did Stemco require you to be SolidWorks certified?
No.
It was just
I never did
experience-wise.
certification classes. And I guess before I got there as an intern, there was no like prove you can do it, especially as an intern. But they did ask like, how much have you used SolidWorks? Are you confident in SolidWorks? But if I got there as an intern, I didn't know how to use it, I wouldn't have gotten hired full time. So.
Gotcha. Okay. So I mean, my next question I was thinking about, what was your interview process for Stemco like coming out of college? Yeah, because I mean, if you had that previous internship experience, I didn't know how formal the interview process was for you.
There was a little bit of an interview, and it was partially because I was getting, as part of the job I was moving into in full time, it was to work with a group that I hadn't worked with before.
Okay.
So I had a more formal interview with that group just to make sure that I met the standards that they were looking for. But I don't think I had any technical interview with anyone from my team, the team I'd worked with. And I had like a generic, like HR interview where it was a panel interview just asking like the different situational stuff, like tell me about a time you agreed with a teammate, disagreed with a teammate, all that.
Right.
Do you think
Gotcha.
Do you think you would have been, like, how likely do you think you would have been to get that job without the internship?
I really don't know.
Do you know if they interviewed any other candidates for your position outside the company, or did they pretty much?
When I was interviewing, they told me they did, but I don't know if that's true.
Yeah, I mean, that's kind of showing the cards. We're only interviewing you, and so I could see them saying that.
Yeah.
And their interview was more of a hi, bye kind of situation.
Yeah.
Okay.
I don't know. They said like the hiring manager mentioned that there were other people involved, but I don't know how much truth or to what extent they were involved.
Gotcha. So when Stemco hires, so like when I worked at K2M, for an engineering position, they made that you had to have a bachelor's in engineering, but oftentimes they had drafters that basically did the same job. However, they weren't given the engineering title. I didn't know did Stemco have education requirements on their design jobs?
I think for new hires they generally did, but there were several people there the type of people who'd been there 40 years, who started working in the shop, who had the title of engineer, and quite frankly were the most respected engineer, like by other degreed engineers, more respected just because the experience they had.
Gotcha. Yeah.
So there was somewhat of a way to like move up through the company into a design like that, job like that. I don't know exactly what their process was through that, just because it happened so long before I was there, but it did happen.
But largely for everything you did, and pretty much to be considered kind of for the engineering department, it was an ABET accredited engineering degree, correct? Like if you were outside trying to get that job?
Yeah.
Okay.
So I guess from STEMCO, what was your, I guess, like the part of that job you enjoyed the most and the part of that job you kind of enjoyed the least?
So I guess my favorite part of that job, I kind of touched on earlier, it's just getting to design something from scratch. And it's never really from scratch. You always come into a project with basically a requirement sheet saying, this is the goals of what we want to do, this is the constraints we have, and then go. It's never fully just, think of whatever you want. There's a budget, there's requirements.
Right.
There has to be something.
In this space. But then basically being able to go from that set of requirements and say, and go be creative, go come up with different ways to do it and settle on the best one.
So I guess what's the counter? What was your least favorite part about that, or least favorite part about that job?
One of the just generic least favorite things, documentation. That was big there. I mean, I guess every engineer in a way says this. It's like
No, it's
always,
fair though.
it's always fun to go and design and do stuff, but then you have to go back and write down what you did. It's just the more boring side of it. One other thing though, at that job, I did get a little tired of the constant upkeep and going out and fixing all the little details. As I enjoyed and got to do more of the new stuff, I got a little more tired of going back and the upkeep.
So was your position there at STEMCO, was it more repetitive design, or was it seemed like it was always a different project that you were able to kind of come up with a different design on? Because my experience at K2M when I was doing design, it was often a bunch of surgeons wanted basically the same tool. They just want it tweaked a little bit. And so it was kind of very repetitive. But I didn't know if yours was like basically just a new project every single time.
Yeah, so I had some of both.
Okay.
The biggest project that was very similar to what you're saying, that was like repetitive design, the same thing tweaked a little bit over and over again, was the trailer tail. So for those listening, a trailer tail is basically fins that go off the back of a truck that are it's an aerodynamic device to make it more fuel efficient. And we have to mount to the back of the door, or basically around what's already there. And the back of everyone's trailer has different stuff on it. It's incredible how different something so simple can be for every trailer. So whenever someone ordered one of those, we would constantly have to tweak the design a little bit to fit around their stuff.
I didn't realize that. I didn't realize those were like custom made almost.
Sorry?
I said I didn't realize those were almost custom made.
Yeah. Well, so that led into one of the cooler projects I got to do, because I got so bored of doing the repetitive design that this is where my computer science minor kind of comes into play and getting to do some programming. I found out that I could automate that part of doing the monotonous design, because it basically followed a flow chart of how to make all the changes. So once I'd learned really well how to do that and understood it, I worked on a program that you would type in some key numbers and it would go do all the work for you.
Well, that's pretty sweet.
Yeah.
Well, so I guess back to your schooling, was there a reason that you wanted to get a computer science minor with your mechanical major, or was it you found you liked computer science and decided you wanted to take more of those classes, or did you have something in mind after school that you kind of wanted to combine both of those?
So really I think it was the second thing you said. It was computer science 1 was a required class. And when I took that, I really, really enjoyed it.
Okay.
And I think I decided it was somewhere in my junior year. I looked at like what classes I would have to take to finish out college. And for the last 4 semesters, it was like 12 hours a semester. So I was sitting there realizing like this could be really fun to have only 12 hours of classes for the next year and a half, 2 years. But then I was also like, I'm here and paying for this anyway. I might as well take advantage of it.
Yeah.
So that I looked at what it would take to get a computer science minor, and it fit in there pretty nicely.
So those of you listening, that is a try hard.
I see both sides of it, because Ben put himself in a position where he only had to take 12 hours his senior year, and so he had room to do it. And I put myself in a position where I had to take 18 hours my senior year, and so I couldn't have done it anymore. Ben and I put in the same effort our senior years. He just got a lot more for his effort.
Yeah, I guess that's a good point. I don't even remember how many classes I had senior year, but
You took a semester off too. You pretend like you're one of me, but you're one of Ben.
yeah, I did take a semester off to go on co-op. So
Yeah, remember, you'd have been a 4.0 if not for Cole. That's your own words.
I guess the listeners.
Thank you for reminding me of that, Keener.
The listeners have to learn at some point. I went to school and I made the conscious, wise decision to surround myself with people that are smarter than I am. And one of those people was Jake, and so he had some high hopes. He was valedictorian in high school. You know, he's going to do good in college. And I had great hopes of passing in college. And so I graduated with the lowest GPA of my friend group, and even brought Jake's down a little. But we had some fun, and I would say it's probably worth it.
Oh, goodness. All right. So I guess back to STEMCO and coming out of college. Like, as a mechanical engineer, I guess what do you think the typical pay range should be for a mechanical engineering graduate coming out of school, has 1 to 2 internship experiences, looking for a job?
Yeah, so I'm going to speak a little like generally, like for most of like middle America, like Texas, my region median for a mechanical engineer who is a entry level is $65,000 a year.
Okay.
And I assume for most of the country, that's roughly the case. I mean, obviously there's bigger cities where everything costs way more, so living cost inflates that. But for most of the country, it's probably around 65.
Okay.
And you were at that job.
That's pretty nice.
Who just graduated with a aeronautical engineering degree, who's applying to jobs. He texted me. He's like, "How do I answer the expected salary question?" So I kind of told him that. I was like, and it basically, the way I saw that question coming out of college, well, I didn't see this. I freaked out just like him. But then I went to our career services department, and they told me what it means. It's basically to make sure that you're reasonable and you've done your research. They don't want you to throw some outlandish number there. So it's like, do some research, find out what the median is for your degree in your region, and, put a little above it. Show them that you think you're slightly above average, at least.
Yeah, it's your first negotiation number, and so it does need to be reasonable. You don't want to shoot yourself in the foot, but also it does need, like, if you sell yourself short, they're going to come at $5,000 less than that. If you're like, hey, median 65, so you put 60 or you put 65, they're coming at you with 60. They don't want to pay more than they have to. It's just the business world, and so that's good. And you were at STEMCO 4 years or 3 years?
I was at STEMCO 2.5, 3 years, somewhere in there.
Okay. With internship, 3 years probably.
Yeah. No, I forgot about adding the internship. Yeah.
Mm-hmm. And then where'd you go to next?
So this is back in December. So 5-6 months ago, I switched jobs to a company in Arlington, Texas called IPS Custom Automation. And what this company does is actually in a way similar to what I did at STEMCO, or the fun project I did at STEMCO, I'll say, but on a contract basis. So what we do is, a company like STEMCO will, let's say they want to design or have a new machine as part of their assembly line. They'll come to our company and say, here's our requirements. We want this machine designed and built and turnkey. You drop it on the floor and it works. So we'll then work off of those requirements, design the machine, build the machine, test it, get it all set up, and ship it to them. So basically my job is getting to do the design and building and all the fun part of it. I mean, obviously there's stuff now that's not ideal. I still have to do documentation and all that.
Yeah.
And documentation actually currently is more of a big deal than it was at my last job. One of the benefits of the machine being, 100 yards from your desk is if something comes up that they don't know what's going on, they can just call you and you can go fix it. So you don't need to plan for every possible failure, because if there's a failure, you can go fix it right away and know what's going on. When you're shipping a machine off to some customer, you're not there to fix it for them. So you have to be a lot more detailed in explaining your process and how you put everything together. So the documentation is, I'd say, more important for what I'm doing now. But yeah, it's basically doing machine design of assembly lines and stuff.
Do you guys ship around the globe or just US?
I think we're just US. Most of our customers are in the defense industry.
Yep.
As far as I know.
Not allowed to be selling to both sides. The US government doesn't like you to do that.
Yeah, probably not.
And so it's just like assembly line equipment. You're not doing like tools or fixtures or anything like that. It's going to be a component that goes into someone else's assembly line.
Well, so it's basically anywhere on that spectrum. It could be, hey, we want you to design this little fixture for us, or we want you to design the entire machine, all of it.
Okay.
Right now, I'm working on a contract for Lockheed Martin.
Ooh.
Okay.
In Arkansas. Cole just got excited. I saw that smile.
Well, it's the big name of mechanical engineering. Like, if you graduate and say you work for Lockheed, it's like a computer scientist saying they work for Google, kind of.
Yeah.
I applied. They didn't accept me. That's okay.
So this project, Lockheed is working on developing a new missile.
The super duper missile.
It's basically like a little bit bigger version of one that already exists.
Ooh.
Is my understanding.
And you don't need clearance, correct, Ben? Just for
what?
You don't have since you're not actually working directly for the government, you don't have clearance, like a top secret.
Correct. Yeah, I don't have a security clearance for what I'm doing right now.
That's cool. That's a nice way to get into defense contracting, I would think, because like Lockheed and a lot of those jobs require that, and that can be tough to get. Yeah. And so you're close to it, but don't have to have that extra piece, which is nice.
Mm-hmm. Yeah.
Well,
so
I guess because you're not technically designing the actual like missile itself. You're designing the assembly line that creates the missile, correct?
Yeah. So I have like a model of what the outside of the missile looks like and all the things I need to interact with. But I don't know what's inside the missile. I don't know how the missile functions. I can guess by looking at it, but what does that mean?
The fire comes out this way.
Yeah. But yeah, there's 3 or 4 machines that. Well, right now there's 3 that I'm working on designing. That one of them, let me figure this out. It's basically different steps of putting the missile together and getting it into its final package. So it starts when we get all these parts. There's basically in 4 different parts, and then we put those 4 parts together to form one big missile. And then once that missile is fully assembled, we designed a specialty cart so they can move it around. And then also, this is the machine that I've had start to finish is, like in the movies, the military trucks that has like it'll tilt up and have a bunch of tube missiles in them. Okay. So that's generically, it's called a pod, what they have them in. So I've designed, and it's currently being built. All the parts are sitting out in our shop getting put together. The pod loader.
Dude.
So once the missile's put together, they bring it over on a crane, set it in my machine, and my machine loads the missiles into the pod.
And are we talking like SpaceX go to the moon missiles, or like model rocket? How tall? I guess it would maybe be.
They're 13 feet long, roughly.
Okay, yeah. So
like the machine that I'm building is 30 feet long, made of 4-inch. The frame is 4-inch steel tubing.
Wow. Oh, okay.
Wow.
That's sweet.
So I guess this is one. I have a question. Like, all right, you get this drawing from Lockheed Martin of the missile.
Yeah.
And then you're designing these 4 different things to assemble and then load the pod.
Mm-hmm.
Like, are you doing a little bit designing, manufacturing in your shop, and then getting components from Lockheed to test this thing out along the way? Or are you just designing off their drawing and they're going to do a final test at Lockheed Martin?
So it's mostly the latter. It's mostly just designing it, and it's obvious. It's a communication. We have a contact at Lockheed, and we have a weekly call, and we're probably on a call with them a couple times a week, just going over some detail of something, of how, like, asking questions about some detail on the missile, and then confirming that that's going to work with what we've designed. When we get to the end, though, we're going to hang on. My dog's jumping in front of the screen.
Zoe.
They're gonna ship us like a dummy missile that has all the dimensions and everything of a missile. It just, won't have explosives in it, and we'll be able to test with it in our shop.
Okay, so
you really don't want the first time you test something under the actual conditions to be in front of the customer. You want it to be in your controlled environment, so that when something goes wrong, because something always goes wrong, you can fix it.
Mm-hmm.
Well, that's what I was wondering, because I was like, if this thing is 30 feet long, I felt like you have to be testing all along the way instead of like waiting all the way to the end just to make sure that this thing's going to function correctly.
Yeah, on this one, it's mostly wait till the end.
That's crazy. The difference, I mean, you talked to some about your STEMCO and processes and stuff, and that was all small components, really. It was wheel end stuff, let's say under a foot by a foot by a foot, a cubic foot. What's the transition been like going from kind of smaller designs you can put your hands on to something you've never even seen? All you have is a CAD model that you can, like, hope works in 6 months or whatever when you actually get the dummy missile. Like, how's that transition been?
So it's made me realize more the importance of attention to detail. So noticing any little thing that's in the model, comparing it to what's in the drawing, making sure everything lines up between those two, because it doesn't always line up because different people make them. Lockheed's a big company. The same guy doesn't make everything.
Yeah.
Right.
But then also, Cole, from working at STEMCO, we didn't have a big requirements document going into a project. You worked in my department as an intern, and it was me telling you, hey, go fix this thing.
Yeah, very, very informal, hands-on. Hey, go look at the problem, solve the problem, 3D print the possible
and we look at it and
solutions.
say, these are the few constraints we have. The difference at my current job is we have a 15-page document from Lockheed saying these are all your constraints. This is everything it needs to do. So yeah, it's a governing document. It's called a statement of work, is their terminology for it. That governs everything you do.
I write so many statements of work. It's sickening.
Yeah. I don't know what they call them, SRP, but we have those too. Whenever you bid out a job, you have to have some sort of contract that stipulates, hey, this is what the requirements are. And usually you would add constraints in that as well. So that's cool.
And even that, the document's never perfect.
Right.
Never.
So that's another thing, like I was saying, attention to detail, and it's a communication process with our contact there. Because it's another person reading it. People aren't perfect; they make mistakes. So when he writes the document, he wasn't thinking about how the whole scope of the project or like some specific interface that his document contradicts. So we have to work through it as it comes up.
Mm-hmm. Do you get to? I know we 3D printed a ton of stuff at STEMCO. Would you ever use a 3D printer to model up 10th scale rockets or anything, and your little cart or whatever, or is that not a feasible option?
We haven't done that. That's actually, we've talked about trying to use 3D printed stuff as some of these test components. Obviously not the 13-foot missile, but one of the machines we designed had it was actually about the size you said earlier, a foot by a foot by a foot. It's like the part of the missile that has the fins on it, the very tail part. I designed these two carts that basically join that piece onto the back of the motor. And and we wanted a fit test to make sure that would fit on the thing I designed before we ship it up to them. So that was we didn't end up doing it, but we talked about with Lockheed because this is, I don't know how standard this is. It's typical of a big contractor, but we're not the only contractor they're dealing with. They're dealing with all these different contractors. Come build it, one person's building the tail, one person's building the motor, one person's building all the different little parts that go inside. So they're managing all this stuff.
Oh, that seems crazy.
And it's all going concurrently. So it's not like they have all the test parts sitting there ready for us when we ask for them. Those are out getting designed and built right now too.
Oh, that seems so insane. It just seems like
it's crazy.
It's not going to line up.
Oh yeah, I mean,
it's crazy.
Do you run into a lot of like change orders and change requests? Like, hey, people designing the fins added a 5th fin instead of the typical 4. We're sorry. Or is it pretty well set
I haven't
out?
had one of those that has affected anything I've done. Oh no, actually there was one. The diameter of the missile changed a little bit.
Oh,
it changed. It changed by like 0.5 millimeter, but just stuff like that, where it's like all these tiny little details that change all the time.
so nothing. It's not like you have to you've never had to like scrap and restart. Like, oh, well, that was a waste of time.
No, nothing that major.
That's good.
So when Lockheed puts this contract out for bid, your company, and I'm assuming several other companies bid on this job, or do you have a contract with Lockheed where you're kind of sole sourced for their work, or do you have to bid on each specific job?
Yeah, it's a bid system. As I'm working on this project, my bosses are bidding future work.
Okay. What's your deadline for this job?
Before now.
Okay.
Ben, well, I'm supposed to be working on it right now, but doing this very important interview for what no one told us. What do you? So,
as a whole, COVID has had a relatively large effect on this, because like I was saying, they're contracting out to all these different vendors, and some of them are closed. The ones that aren't closed, we've been open the whole time. I worked from home, but that's just bring my computer here and I can work.
Yeah.
But the people supplying us with stuff, some of them are closed, so it builds in all kinds of delays like that. So the original due date's in the past, but situations changed. COVID's been a big one. Pushing stuff.
Okay.
On a huge team like that, especially with hands-on manufacturing, it's going to be the deadline just has to get pushed because there just hasn't been able to come.
One example, one of the biggest things for us was we had this part that was coming out of Italy, and Italy got completely shut down for a month and a half, and we ordered the part 1 day too late, so we had to wait a month and a half for this part to come out.
Yeah, and that's
that's the same thing that happened to Shane.
They can't complain about it because it's there's nothing that can be done at that point.
Right. So I guess your job there, what is your specific title? And then also, what was your specific title at STEMCO? I don't think we asked you.
Yeah, so my title at STEMCO was Product Applications Engineer.
Okay.
Which that was more the monotonous, boring job I talked about with the trailer tails. That was technically what my title was, but it was only max 40-50% of my job. So the other time was spent doing that process machine design work.
Gotcha.
My current title is Automation Engineer.
Automation Engineer. Okay.
And then what does a day look like for you, Ben? Like kind of everything. You get up, what do you have to wear? Are you suit and tie, jeans and a t-shirt?
The dress code of my current company is pretty laid back. It's today I wore jeans and a t-shirt. It's usually jeans and a polo.
Okay.
But it's Texas and it's hot, so the bosses are you can wear shorts if you want to.
Oh, yes,
wow.
Please. Yes, please.
That's not what STEMCO was like. STEMCO was jeans and a polo usually.
Okay.
So
and then you're all 40 at work.
Not I don't have to wear a button-up shirt and a tie. So
And then you're in the office for 40, typically, like we're talking pre-COVID, post-COVID. You're in the office 40 hours a week. That's good. Okay.
So you mentioned when you were doing these designs that you were doing some manufacturing in-house for your designs. Are you going to do most of the manufacturing in-house, or do you like contract that manufacturing out? Or are you mostly just design work?
So we do have a manufacturing shop
Okay.
in our building right now. So most of the parts get done there. We don't have the capability to do massive stuff. So like the giant frame for that pod loader I designed, it's 4-inch tubing. The whole thing gets welded up and it's total like 30 feet long. We don't have the capability to do that. So we contracted that out.
Okay.
But all the components that are going into this primarily were done in-house.
Okay.
Which that's one of the nice things about having that machine shop in-house is, as I'm designing stuff, I can go to the guy who's going to machine it and say, hey, if I design it, be it like A or B, which one's easier for you to make? So it, to me, it makes no difference. It's a click in SolidWorks, but to him, it could be 5 hours.
Yeah.
Right. Yeah. It's a big deal on the other end.
Yep.
Yeah.
And then you mentioned that your current company is a little smaller than your previous company. What's the size of the company you're working at now?
The design team, there's three mechanical engineers, 3 controls or electrical engineers doing controls. There's like 4 or 5 assembly technicians who, that's basically like I was saying with the pod loader, all the parts are sitting out in the shop, but they need put together, so that's their role. We have 3 machinists, and then there's like a couple operations people just running stuff.
Okay, so 25, 30 employees.
Yes.
Not great at adding, but that's cool. So that's a small, and then privately owned, I assume, right? You know the owner, he works with you guys.
Yeah, there's 3 owners. It's the president and the 2 VPs that I work with every day.
Yep. Okay.
Okay. So, I guess one of my questions are like this project, this pod loader for this rocket, is this the only project you're working on now, or are you like working on several different projects at the same time?
Currently, I'm working on several different ones. I've actually currently
Okay.
have 3 projects going on that are in different stages. So there's the pod loader, which at this point I've designed everything. I've made up all the assembly drawings that like show the assembly text how to put it together. So now I'm just in like answer question mode. So as they're going, if anything comes up where the drawing's not clear or they want to double check something or something isn't going together right, they come and get me and I go figure it out, solve the problem. There's another project that I inherited from one of our other designers that we already made one of, but it was a very rushed job to get it out the first time, and there were a lot of like on-the-fly modifications we made. So my role was take the SolidWorks that already existed and update it to what we actually made. So update it to what we actually made, and then go back through, make all the assembly stuff, because we're making 2 more sets of the exact same thing. So we want the documentation to match what we actually are physically making and what we sent.
That's definitely one nice thing in the industry today, that like a CAD model is considered documentation. With like 3D PDFs, kind of everybody having access to a computer, there's not near as much drawings as I imagine there was 5 or 10 years ago, and that makes me happy.
Yeah, there's less, but I'm still doing like all the way down the chain sub-assemblies with exploded views showing how bolts go into which holes and everything.
I was gonna say, you have to have drawings all the way down, right? You're not just giving them the model.
No, yeah, we're doing drawings all the way down. So for example, the pod loader, there's like, I think somewhere around 60 pages of assembly drawings for how to put the whole thing together.
I stand corrected.
Right.
People still want the drawings.
Yeah, Cole, that was the same thing at K2M. It was like, no, you have to draw everything because the machinist, his documentation is the drawing. His documentation is not the model. If the drawing is wrong, then he's going to make it wrong, regardless of what the model says.
That's lame. That's just pure lameness.
Yeah, so, and that 60 pages was just the putting it together. There's also another 100 pages of each individual component that gets machined a drawing for that.
Wow.
Oh gosh.
And you've done all that, or is that?
Yeah.
Wow. Since December.
Hmm?
I haven't made that.
Yeah, I started that project in January.
Oh my gosh.
Wow.
January.
I've never made that many pages of anything in my life.
A project.
What'd you
All
say?
right.
Ben?
So.
Go ahead, Jake.
I was just gonna say. Oh man, that is so many pages of. That's
Dumbfounded.
rough.
Yeah.
So after this is all done, and you make this and it works, I'm assuming all of these drawings are just sold to Lockheed Martin. Like, do you keep copies of these, or is it just like this is theirs now?
We keep copies of it, but yes, part of the contract is they get the book of drawings when it's going to be done that shows them how to make the thing again.
Okay.
It's their intellectual property.
That's not to like that they're gonna build the thing again, because most likely if they want to build another one, they'll come to us and have us build it again. But also they could, submit another contract to a bunch of other companies and say, hey, we want you to build another one of these. Here's the drawing packet. Do it.
So they own the design
Yes,
as
they
well
own
as
the
the product. Okay, that's cool.
Okay. Yeah. Do you get involved in the looking and bidding for new work at all, or is that just like the owners are out there putting contracting or putting bids together for contracts?
I haven't to this point.
Okay.
I doubt that I'll ever be involved in like looking for new business. I would assume at some point I'd be involved in bidding new projects.
Gotcha.
Just saying this is what the machine needs to do. One big thing is like bidding engineering time. They can come to me and say, how long is this going to take you to design? And then how much do you think the parts are going to cost and labor and all that? So that's where I assume getting involved in that in the future.
Do you know how much the pod loader contract was awarded for?
I don't. I can look at it. I have access to it, but I haven't looked at it.
Have to text us that later. We're not on the air.
Yeah.
It's bigger for sure.
Yeah. Yeah.
Say it rhymes with smillion.
It starts with a B. How much computer time versus shop time are you looking at? A lot of engineering positions are 50-50. A lot of them are 100% computer. So, kind of on your normal day, are you getting up and talking to the machinists, or are you pretty much usually at the computer, occasionally talking to people?
It's probably 75-25.
Okay, that's a good balance. I like that.
The computer, but there's a lot of talking to machinists. Right now, it's probably a 50-50 split because I have that big project out there getting assembled, so I'm constantly out there working with that. But probably it'll probably average out to 75-25. Like during heavy design stuff, for most of the day, I'm just sitting at my desk on the computer. But it varies and goes in waves.
Yeah, I think that's one of the biggest benefits of a small company is it is fairly dynamic. And right now you're on a project that's getting assembled, so you're spending some time in the field. And next week it could be a really design intensive or whatever. Next 3 months it could become a very design intensive process where you spend a lot of time at the desk. But it's always changing, and that keeps somebody interested, and I like that.
Yeah.
Yeah, that's pretty nice, man. I'm still thinking about those hundreds of drawings. I think of that and it makes me
cringe.
I just cringe. That's something I just would dread doing.
Yeah,
I actually went and looked at totaled it up. The pod loader, I think there's I made another one today, so this number may be off by a couple, but 105 parts that I've designed, and there's something like 250 to 275 individual parts, and a lot of those are fasteners and stuff that are off the shelf from the vendor. But there's some 275 individual models in the whole thing.
That's insane.
Wow.
That
is insane.
The design sounds exciting, but just if somebody's like, hey, you get to design this, I'll give you money, but you have to do the drawings, I'd be like, well, I'd rather starve. I'll go lick some door handles and get COVID and die in a corner or something.
So the other engineers you're working with, are they working on their own separate projects, or are you kind of like in collaboration together, helping each other out on the same designs?
That's another thing that's shifted a little bit. Early on, I was working a lot with one of the engineers, but then, there's other business, other projects, so he's got mostly pulled off to that. I still go ask him questions, like if I'm specifically, I'm working on the project that I got inherited a project from him, so I'm asking him a lot of questions to get up to speed. But then also, as I run into an issue, I'm like, hey, I ask him like to solve it together, come up with more ideas. So it's not completely isolation, and that's another thing that varies. Like depending on the size of the project and the urgency of it, there'll be multiple of us working together. But yeah, it's another thing that varies.
Do you get an office? Do you get are you like office, big sign says Ben Keener, the boss hog, or anything? Or are you like cubicle?
I have my own room. It's not technically an office because there's other desks in there, but no one else is in there.
No, that's an office.
That sounds like an office to me.
That sounds like you need to like mega desk it up right now and be like.
I've thought about how I want to arrange it to lay claim to the whole office.
Yeah, just kind of like, oh, hey, I don't need these desks in here right now, and then just never get them back, and then like all of a sudden you have.
Well, the problem is there's 4 desks in there, so I can't like make a big area out of 4 of them. I could use like two of them.
You could definitely use all 4. What are you talking about? Make a ginormous U, just like, just like, and have yourself face the door, so when people like walk in, it's just like you and like a bunch of desks. Hi, how may I help you today?
With my 2 little they're not little, but 2 monitors on 4 desks is pretty small.
I have 4 monitors on. I don't even really get a desk. It's like a place to set my keyboard, but I got a lot of monitors.
That's nice.
That's nice. So I guess comparing this job now to STEMCO, I guess what do you like more or less about this job compared to your last one?
I'd say so far I like the newer job better. And that's mostly just because it's more of the thing I enjoy doing the most. Like I've said a couple times, the part I like the most is doing the design, coming up with something, and that's more of what I do here than it was there.
Okay. Is there anything that you think's like a down, or not necessarily a downside, but you don't like necessarily enjoy about this job?
Nothing too big yet, I don't think.
Well, that's pretty good. Yeah.
I'm enjoying it right now.
I guess kind of next question, like after mechanical engineer, have a couple years, a year's worth of experience, what is like an expected pay increase if you were a mechanical engineer, wanting to go into the field, trying to see what you can make after a couple years?
Trying to think, just like rough, like percentage wise. I'm terrible at doing percentages in my head.
Yeah, that's okay.
I mean, over the course of 3 or 4 years, your salary going up 10 grand is a pretty reasonable thing, I would say, somewhere around there.
Okay.
Okay.
And then do you think switching careers, you're able to leverage your previous experience to get a bigger bump than just like the standard merit increase or, like cost of living increase?
I think in general, yes. I think when I was in college, one of my professors told me there was some statistic that's like, in order to maximize your earning potential, you should switch jobs every 18 months because then you'll get a bump more often. Like
wow.
That's, looking at an optimization for it, but I don't know what it actually is in the real world. I've had 2 jobs, so it's hard to tell.
Yeah, you're not jumping around too much. Yeah, that's cool. As we kind of wrap it up here, one of the, I guess the main question of this whole podcast is what no one told us, and is there anything that you feel like you didn't expect when you got into the workforce? Like you had a pretty good idea you wanted to be an engineer, and kind of excluding what you learned in your internships. Like what have you learned that was surprising in your internships and jobs after college that you're like, oh, I really wish somebody would have told me that when I was in high school?
So this was a benefit to me because of my computer science minor, which we talked about it earlier. I did because I liked it and I thought it was interesting. But basically, be versatile.
Okay.
As a mechanical engineer, if all you can talk about is how gears work together and how to calculate stress and strain, yes, you're going to be valuable for those things. But engineering and the workforce, you work with different people, you work with different groups. So having taken computer science classes, I can communicate and talk the same language with a programmer who's going to program the machine I build. So you can work together easier with them. Electrical engineering, that's one that I kind of wish I knew a little bit more of. All I took was circuits 1, so I know how to calculate resistance, which is useless. Not much.
Yeah.
But yeah, so like that's an area where like if I knew a little more, it would be easier to work with the guy setting up controls and everything for this. So the more you can expose yourself to, it'll make your life easier, but it'll also make you far more valuable as an engineer because you can work with so many more people and speak the same language with them.
That's good advice for sure.
I was gonna say, yeah, Ben, that's really good advice. And I would definitely agree with that just from my experiences at K2M and then now in the hospital environment. Like the more you can relate to different people, the easier life gets almost.
Yeah.
There was one more question I wanted to ask. So in education wise for mechanical engineering or engineering in whole, it's usually like, a bachelor's in engineering, and then there's the FE exam, which is your fundamentals of engineering. And then there's your PE exam, your professional engineering license, or there's also the route of going, like you could go get a master's in mechanical engineering.
Yeah.
What do you feel like is the most beneficial for a mechanical engineer, or does that depend on basically which area you want to go in?
Yeah, so I think it very much depends on what you want to go do. So like the FE, the only reason to do the FE is if you want to go do the PE. So, and to get a professional engineer's license, there's some value there because I think in general you earn a little bit more for it, but it's primarily like specific industries that look for it. If you're going into an industry that doesn't care if you have it, they're not going to pay you any more for it.
Right.
So Cole, you know this because of your dad, but civil engineering is a huge one where it's very important to have your professional engineer license. For what I do now, there's not really a benefit. So I haven't taken the FE because in the industry I'm in right now and the work I'm doing, there's no need to. It doesn't benefit me at all. There are jobs where having a license is a requirement. But if you don't have that requirement, there's not a major benefit to it. And then on the like further education side, again, it kind of depends what you want to do. So one thing that going throughout college, most of what you do in college is they teach you how something can break and they show you how to calculate it. So I guess structures is an easier one. Like a bridge, they're going to tell you how to calculate how much weight it'll take to break it. And in your undergrad, your bachelor's degree, it's relatively basic. And me right now, like I'm out doing a job, I don't really ever calculate how much force it is to break it, but I know what's gonna break it. Like I know what type of things lead to breaking it and how to avoid that. There are jobs where your job is literally to calculate stuff. Like bridges, they actually sit down and run the numbers for what's gonna break this. And if you want to do a job that's more analytical and running numbers, that's where getting a master's and PhD in engineering becomes more valuable because those are the types of degrees you need to get those roles.
Okay.
Me personally, I've thought about going back to and getting a master's in computer science, but that's mostly just to learn more about it because I find it interesting and I've enjoyed getting to do it when I got the opportunity. But that's just further learning experience, kind of like what I was saying off of earlier of make yourself more versatile, know more stuff.
Gotcha.
really like-
Yeah, I mean, I think it's a good answer. Cole, do you got any other questions?
I don't think so. I think Ben summed it up nice. He had a better idea what mechanical engineers do than I do, and I'm a mechanical engineer, so he did a good job explaining
Well,
it.
I mean, both of you are in very different jobs. You know, Ben's more doing design, whereas you're not doing design at your job.
No, not even a little. Yeah, we do.
That's what I kind of touched on at the beginning is mechanical engineers can do so many different things.
Yeah.
My first day of engineering class, intro to engineering, the professor gets up there and basically goes over a brief description of what each different major is. And his description of mechanical engineering was, if you see a thing made of stuff, a mechanical engineer was involved.
Oh my goodness. I guess I have one more question. Do you feel like your schooling experience prepared you well to go in as a mechanical engineer in the workforce?
I do. And like I was just saying, it's knowing, I guess a lot of design is figuring out how stuff's going to fail and figuring out how to not get it to fail. So like I was just saying, all the schooling shows you really well the different ways things can fail. I mean, obviously there's stuff you learn on the job that they don't teach you in school. One basic one that I didn't know till I started as an intern, and one of the engineers I was working under started saying something to me, and it was like he was speaking a different language. So that was specifically like different bolt sizes. I'll give you an example. Like he would say 1/4 by 1 inch, and I'm like, what does that mean? Well, there's a code for how you like say the different sizes of bolts, and they didn't teach me that code in college. So there's always small stuff like that. But in general, I do think I was prepared pretty well for the jobs I've done.
Okay. Gotcha. Well, Ben, I think you answered all of our questions really well and provided a definitely good insight into what a mechanical engineer does whose focus is more design heavy. I just thank you for coming on the podcast. Cole, if you have any other questions.
No, I don't think so. Thanks for joining us, Ben. It was a pleasure to talk and learn about what you do.